Hello everyone. Today I want to talk to you about HMAC, or hash-based message authentication code, which is used to ensure the integrity and authenticity of messages in traditionally a two-party communication system. So in this case, we have our party A, which is Alice, and we have party B, which is Bob. And Alice wants to send a message to Bob. And in this message, Alice is going to have some text, and Bob wants to ensure that this text has not been altered with or tampered with in any way. So the bottom line is, Bob wants to know that Alice actually sent this message and that it has not been altered by some other party. So that's one thing. There are two important things to remember when implementing HMAC. Alice and Bob need to trust each other. That's the first thing. You need to have two trusted parties. If Alice, for example, doesn't trust Bob, or this whole thing doesn't apply. So that's one thing. The other thing is that Alice and Bob need to share a secret key. And this key is later used to generate the HMAC. So there has to be a way for Alice and Bob to securely exchange a secret key. But that's the bottom line, right? So if there's no way for Alice to securely share a key with Bob, it doesn't apply. And sharing it through the same channel wouldn't be secure either, because some other party would get the key potentially and be able to tamper with a message without Bob being able to detect it. A message that Alice wants to send contains some text, and Alice is going to generate a HMAC by inputting a key along with her text, and it's going to be inserted into a hashing function, which I should say nowadays of usually the SHA-2 family, or SHA-2. And this is going to give a hash as an output. This is our HMAC. Now, when Alice wants to send a message to Bob, we're going to use this generated HMAC in our message. We're going to add it to the message. So our message itself consists of the text as we would want to send it, and our hash or our HMAC. And we're going to send this to Bob, right? When Bob receives this message, Bob is going to want to verify that this actually comes from Alice. The way they're going to do that is by looking at the hash or the HMAC that Alice generated. And Bob is going to generate their own hash with the same hashing algorithm that Alice used, and the key and the text. So Bob receives a HMAC of Alice. I'm just going to write that down here. We're going to need this in a second. HMAC, and this is the one of Alice. So we have our hash A, which is from Alice. And now what Bob is going to do is Bob is going to input the text that they got from Alice. Along with the key that was exchanged securely previously. And this is going to be input into the same hashing function that Alice used. So in this case, that would also be something in the SHA-2 family, the same hash function as well, which is going to output a hash. This is going to be Bob's hash. If these match, that means the key and the text have to be the same. If they don't, it means the message or the text has been altered with in some way. So either the key for some reason differs between Alice and Bob, which is unlikely because we exchanged it previously. Either the text has been altered, or finally the hash itself is altered. In either case, we can determine that this message is not authentic because it has been altered after Alice generated it along with the HMAC. So this can be used to determine that a message has not been tampered with or altered. What HMAC does not guarantee is that a message is not read by other parties. So if you want to prevent that, you could use an encryption algorithm to, for example, create ciphertext of the text and then input that into your hashing function before creating the HMAC. So that way you can have ciphertext as input along with your key to generate your HMAC. So that way you can, in theory, get a message that is both unreadable by other parties and a message that cannot be tampered with. But, as I mentioned, HMAC only guarantees the latter, that a message has not been tampered with. And if you implement it correctly at this point in time, it will guarantee this. There's currently, as far as I know, or as far from what I've seen, this is reliable. So to summarize, you will need to utilize a secure and separate channel for exchanging this secret. And if you send it via a channel that is not secure or potentially insecure, it negates any trust or validity that HMAC can establish, and there's no point to using it anymore. The other is that you will need to store a secret key in an appropriate manner so that it doesn't leak, because once again you will have the same situation as before, and as such you would not be able to trust the whole protocol to verify the message. Now, when Alice generates a message, the first step is that the HMAC is calculated using the shared secret key. So this could be this could be generated using text along with the key, or for example an encrypted text or ciphertext, etc. Bob is going to receive the message next, and Bob is going to check whether the HMAC they generate, as I showed you here, is going to correspond to the HMAC that Alice sent to Bob. And if they match, we can verify that the message is authentic. If they don't match, it's definitely not authentic, and in any case, it can never be trusted. So if you rely on this, make sure to make that distinction. HMAC offers three things. It offers you integrity on the data sent. It offers you authentication, because it means that Bob can determine if a message was sent by Alice. And it offers you protection against some form of attacks in the process. So here's a quick diagram to show you that Alice sends a message along with the generated hash or HMAC. Bob can determine, hey, this indeed matches what I generated to check. And as such, we have verified the integrity of the message. We also have a second scenario in which Eve might be tampering with the message. So Alice is going to send a message along with an HMAC, and Eve is going to tamper with it. Now this could happen, for example, if we're on an insecure channel, some other party could act as a middleman and intercept the message, and maybe send their own version of the message later on. Once Eve has intercepted the message, it could be modified, but because Alice originally generated an HMAC of her message, it's not going to, the hash that Bob generates is going to mismatch the hash that Alice sent, which means we have a failed HMAC verification, and as such we know that Bob cannot trust the message that was sent. So this means that the key does not match for Alice and Bob. In a scenario where the key has been altered. So, for example, it's also possible, although unlikely, that the secret key has been altered. Maybe it's been updated for Alice or some technical issue. caused it to be different. So if we have a mismatch, that's the first possibility. The second possibility, and by far the most likely, is that the message has been altered since Alice generated the HMAC. So, as I mentioned, in this scenario, Bob can conclude that the message is tampered with. Now let's take a look at a very simple implementation. This doesn't do anything with actually sending a message. This implementation simply shows you how you can generate a hash, which is your HMAC, right? So we have a secret key, which is this right here. We have a message or text, and we're going to generate an HMAC with our message and our secret key, and we're going to save that to a file. So this is what the sender would normally send in their actual request or their communication protocol. Then we also have the receiver, and the receiver is going to determine that the HMAC that they generate, so based on Alice's message, they're going to generate their own HMAC. It has to match the HMAC that Alice sent. If it doesn't, we cannot trust it. So that's the basic example of it. Note this is like a very basic variant. You could do a lot more with this. There's one other thing I want to discuss. Since HMAC does not guarantee that a message has not been viewed by another party, we can also use ciphertext for that, or encryption. So if we normally, for example, had a text that said hello, we could just do some encryption or a cipher algorithm over it. We'd end up with ciphertext or an encrypted text, and it could be something like, I don't know, just making something up here. BVP, and instead we could simply input this into our hash function. So that way the sender can also send encrypted text, right? As in our message right here. So that's it for this video. It's a very quick and rough explanation of HMAC, but nevertheless, I hope you found it useful. And I hope this gives you a bit of an idea as to what you can use it for. You can also view this repository. I'll leave a link in the description. It's something I have been messing around with a bit and I wanted to share. So yeah, that's it. Thanks for watching.